So, why? It's LiDAR. Everyone, you need LiDAR. When you say Tesla doesn't have LiDAR, there's all these complaints. It needed LiDAR. It has to have LiDAR. So why isn't this working? So I had Claude explain to me a little more as if I was a 5-year-old. Why doesn't this work? It doesn't really make sense to me. The LiDAR is there, and I do understand when you see the Unitree with like research and stuff like that, they put another LiDAR right on top of its back. Why? It has a LiDAR. Why do you need to put a second LiDAR right on top of it? That doesn't really make sense. So I asked Claude again, like, explain to me what the difference between these two are and why I would even go that route. Why would I put one on its back when it already has one? And it's not a bad LiDAR. And so I had to create this document. And so this is a plot of what is actually happening with this LiDAR. One of the things I tried to do, I experimented with, is I wrote this software, or I had Claude write this software really. And it basically just said, okay, take this map and now plot it. So plot out what you see in that map, and then let's dissect why I can't navigate with it. And one of the biggest things I was running into was that I could see, so I have this diagram here, I could see everything as far as, again, I have this rectangle and I have this other area and I have all this red that I say is a wall. So why isn't this working as far as saying these are walls? Right? This is what the fundamental problem I believe I'm having is that for whatever reason, this is not considered walls to the navigation processing. So I looked, I tried to write some software that would say, okay, let's just start to refine this a little more and pull out that wall information. So okay, so I had it go through and try to find the walls. It wouldn't really draw these all out. So the question became why? Why can't I do that? And so what I had is this diagram come. And this diagram is basically showing you the Go2's LiDAR. It's mainly hitting the ground. If I hit reset and pause, this is one pass. So basically, as it's scanning, what does it see? And it'll see the wall, but it's very sparse. Of all the points that the Unitree Go2 put out in one iteration, only 40% of the wall was hit by the LiDAR scan. Okay? So if you look at a Go2 LiDAR versus, say, like a Velodyne VLP-16 or the PANDAR-40, what is different about the Unitree L1 LiDAR that's on this Go2 is it's what they call a non-repetitive LiDAR. So these lines here on the first pass, on the next pass, will have additional points. So you'll get a more dense look outward as you are scanning. So the longer you look at one spot, the more dense of a picture you get until you can see the entire wall. But if you're walking, that means the faster you walk, the less of everything you're seeing. So again, if I reset this, the first pass will only see the wall with a couple points. And then I walk and I'm now looking somewhere else. The amount of points that I've actually hit the wall is very small. It's not a large amount. If I were to walk, stop, wait, walk, stop, wait, walk, stop, wait, and continuously do that, then I will start to get a better picture of the wall. And that's where, when I look at this plot, in some places the red is very dense, and in other places it's not as dense. And it's just because I sweep through and walked, but I never slowly, step by step, walked in a more constructive way to start building out the entire wall. On top of that, it doesn't see as much of the wall when it is going. It sees a lot towards the bottom, but not as much as it's going out. As the wall gets closer, and I play this through, it's basically the same problem, that even when I am close and I'm only looking at it for a short period of time, I'm not getting a very large density on the wall. And so it's basically saying that in one pass, I only see about 32% of my LiDAR actually saw the wall. So not a very large amount of my LiDAR saw the wall. And then if I were to just sit there and just collect data, then all of a sudden this wall density will increase, but it's still a lot of my LiDAR data in this particular configuration looking downward is more seeing the ground and what's in front of it, directly in front of it. So it's more there for obstacle avoidance. It's not there to scan the entire room. So the LiDAR is not getting full utilization looking out. So what if I put that same LiDAR on its back? What would I see? And so I had it make that. So I'll turn this LiDAR off, and I will say, instead, let's put that LiDAR on its back. And you'll see now that I get a larger amount seen. And again, you see this non-repetitive. So in one iteration, it saw one point, another one saw another point, another and it saw another, and it's just basically moving around. And that's what the actual L1 is doing, is it's moving around. So it kind of sweeps. So if I were to use something like the Velodyne VLP-16, that one doesn't do this sweeping motion. It just shoots one out and another and another and another. So you get 16 lines, but at least I get to see the wall. And the wall is mostly what it's looking at, right? It's not really looking down for obstacles. Now it's looking outward. It's looking more onto the wall. And I get a good density when I am up close. And as the wall moves further back, I'm still getting about that same amount seen. Just now I'm not getting as much density, but at least I'm seeing wall more than I'm seeing floor or directly underneath my head. But you will see here that I am losing some now to under my head. But I still am keeping that consistent. And because this is non-repetitive, it's the same point that it sees every single time if I were to sit stationary. So I'm sitting stationary, looking at the wall. It does one line, one line, one line, one line. In the L1, it did line, 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 and it just keeps sweeping. So one pass it was here, the next pass it was here, the next pass it was here, and it's doing this little more density to it. So not a great density at 10 meters, and then further out. So now we're really far away, looking at something far out. I am hitting it, but I'm not getting any density really at all. I'm getting 8% of my LiDAR is actually hitting it, where everything else, half of it's hitting the floor and half of it's just shooting away into the ceiling if we were doing this indoors. If I were to then switch it to the PANDAR-40P, instead of 16 lines, now I have 40 lines. So I get a little more density. So again, in the back, when it's further, I get a little more points. When I'm up close, a little bit more. And then when I'm up close, even further, I start to hit that wall a lot better. So I'm getting a little bit more on the wall. I'm also hitting the ground, so I get to see some obstacles close up. Not directly in front of me, a little bit further out, but at least I'm seeing obstacles and I'm also seeing the wall versus the VLP 16. I didn't see as much of the wall and I didn't see as much on the ground. It's kind of a mix of the two. And then the one that everyone seems to be using right now is the Mid-360. I can't afford that one right now, so I can't afford to test this, but the Mid-360 sees a lot. It doesn't see a lot directly below, so it's not great for obstacle avoidance, but the density on that wall is intense. If I go further out, It's still, again, this is a non-repetitive one also, so it's getting you a lot more density in what it can see, and it's moving out. Okay, so as it goes even further, where before we were having 2 or 4 lines, now we're seeing a lot more density. 68% of the wall is still being seen through this Mid-360. So expensive right now. I don't have the funds to just buy one of those, but I did buy the PANDAR-40, the VLP-16, and the Unitree L1. So the plan is shove these onto the back of the Unitree Go2 and see what I get. So, of course, they come with nice, complicated connectors. I do have the connectors already from Amazon for the VLP-16, but the Pandar one uses an older Limo one that is not popular anymore. So that one is taking a little bit longer from China. I have to wait for that. And then the Unitree L1, this is a moving exposed LiDAR. So it gets a little more complicated with this one. Usually they have like a little frame around it because this is spinning. So I got to worry about that. But wiring on this one is a little easier. This one is using USB, where the other ones are using network connection. So they'll use an Ethernet port. So the next plan of attack for that is build out this fixture. So this fixture will house, there'll be 2 layers of this extruded aluminum. There actually possibly be 3 layers. One for, there'll be an IMU, and then there'll be the Jetson Orin Nano, and then the LiDAR right on top of that. And the plan is, not only is this going to work for the Unitree Go2, because that's what this plate is for, but make this mounting portion adaptable to find a way to mount it into my my R2D2 and my Unitree, or my Robo Scout. So it may not use this exact setup, but I'll be able to have that mounted on. So that's the next plan of attack in this, is to see what I get out of using a VLP-16 or a Pandar mounted on top. This guy's heavy, almost double the weight of this VLP-16, but this only outputs 16 lines, where this one outputs 40 lines, so I will get a better density, as you saw in the plots. So yes, I will make it so that I can run them both, but I'm running on to the limits of what the Unitree Go2's payload is, so I may have to worry about that. Me from the future, I was able to get not 1 but 2 of the Livox Mid-360s, so I'm adding those also to the packages of testing for all these different navigation systems, and you can see it's coming along. Okay, that is step number 1. Again, I'm looking at this always though, and I don't see these big ass things on, say, like the humanoid robots, right? They're not using these giant LiDARs mounted to their head, walking around. So what are they doing? How are they getting around this problem of mapping, understanding the environment, and then also obstacle avoidance? And what it is depth cameras. So the next step was, okay, if LiDARs are there, what is the depth camera going to give me that the LiDAR is not? So again, I had the same kind of software setup, but this time I'm now utilizing a depth camera. So I first started with, I have a D435 and a D435i. Same thing, just one has an IMU, one doesn't. What would that do for me? So again, these are up close. What with the density of the wall being captured, I basically see the entire wall. Plus, I get to see what's also on the ground. So I am going to be able to do obstacle avoidance and see the wall. If I then go further out, say 10 meters, the D435 is right at the edge of its limits of what it can see. So with the LiDAR, I could see out 10 meters, no problem. With the D435, 10 meters is basically where I cannot see anything anymore. I cannot see past 10 meters. And even at that 10 meters, the simulation here says you won't even see the wall at 10 meters away. It's like 9.8 or something. Okay, so what about then the D455? Another one, slightly different, slightly larger. What would I get out of that? And it turns out less range, more density on the bottom though. So if I were up close, I would get a nice mix closer, up close, and I would get a nice overall wall, but now I'm limited to about 6 meters range. So I lose some of that range. And then if I change that now to back in the day I had a Z. So this is the original Z. It requires CUDA. So you can't just run this. You have to run it with a CUDA processor. So it has to run on something like a Jetson Orin or a Jetson Nano. But the range is there then. So at 10 meters, I can see everything. I can also see everything up close. Again, object detection, obstacle avoidance, but also mapping, seeing the wall. So again, depth cameras seem like the way to go. LiDAR just giving me that extra range. But I may be able to just accomplish this all through depth camera with falling back to the LiDAR when needed. And again, this is kind of where the Tesla thing comes into play. Is it camera only or camera and LiDAR? What is going to be better? That's what I'm going to find out. So this is the ZED Mini. It's a little bit, no, this is the Zeds, all right? The ZED Mini, a little bit smaller packaging. I don't have the next iteration, whatever that is. Again, these are all getting into the more expensive cameras now when you get the latest and greatest of all these depth cameras. But the ZED and the ZED Mini will give me at least 10 meters. I believe in the house environment, that's fine. Outdoor, I'm not really worried about running into something that is more than 10 meters away, 30 feet away or something. So yeah, those kind of situations, even when I'm outdoors, I'm not using this in like a car where I'm going to hit that 10 meters real fast. It's going to take some time to get there. Okay, and then last is the Oak D Pro. So just like before, I have a bunch of these cameras that I've acquired over the years. So I have this is the ZED Mini, the original ZED, big boy, the D455. This is the D435. This is the Oak D Pro. So I have that one also. And again, all I'm doing is just looking on eBay, looking on OfferUp, looking on Facebook Marketplace. If I see any deals, my goal is to be less than $100, $150 for all these sensors. So like all these LiDARs were under $100 at a bottom, and they were working ones, not the ones that's untested or for parts only. These ones that they claimed that they were working. Same thing with these cameras. I'm $100, $150 max for all these. I think most of these cameras were like the newer RealSense ones were in the 150. The older Z ones were like, I don't know, $70 or something like that. So I have been continuously looking for all these. I've got a couple of D435s and one D435i. And one of the goals is, again, now with all this, things like my R2D2. Let's see here. I can put something like the Z camera in there and it'll look pretty good. Or the Lux D Pro also looks pretty good in there too. As far as like, I don't have to do a lot of making it not look like it belongs. So here or here, I'm going to repaint this all black again. I tested it out in white. I didn't like it, but put it in here where this is. I can just remove this piece and put that in there, but I can have that. The LiDAR fits on here, actually in this hole, this exact size. So they're almost the exact same diameter. So I could have that there, or I can put the Unitree, the Unitree L1 also looks really good on there. If I were to put that on top. Now I'd probably angle it so it's level. I don't know yet if it's going to look good that way and work well that way as far as being angled down or up. But that's what part of the testing is going to be. I want to get my R2 at least functioning with the depth camera. My goal is to get the R2 working with the depth camera by beginning of May. There's an event it's going to, and I'd like to be able to show off using a depth camera with it. That is the easiest integration right now. I can shove a Jetson Orin in there. It's already got motor controls. Now it's just wiring it all together. So I got to get it first on the Unitree Go2 just so I can start testing some things out, just to understand what limitations I'm going to run into now. Just like I did before, the navigation is not working. Will it work quickly with camera, with a LiDAR? And if it does, I'm ready to go. But if you guys have any suggestions, if you want to see one of these specifically first, leave it in the comments. I'll try to prioritize based on what other people are looking for. But for me, it's now just starting to test these sensors. So the next videos are more going to be geared toward, here's my setup, here's the results I saw. Here's my setup, here's the results I saw. I'm not gonna lie, using Claude now, Claude Code, with the ROS 2 environment, I don't mind using ROS 2 now, because I basically just tell Claude, hey, this is the other device I want to add to this launch file. Find the drivers, install the drivers, and get the launch file ready for it. And the Unitree Go2 is nice again because it's pretty much a universal platform for a lot of research. So everyone's already done all the legwork for me, and now it's not me having to do the research. How do I stitch it all together? How do I reorganize all of it? Now it's just Claude Code, do that. So AI working for me as a programmer who's been doing this for over 30 years. I like Claude Code. I understand the process of making it work for me. I like the research side of it, that I can keep asking it questions. We can keep iterating through the code. So I find using it very helpful. And you can see from all these plots that I've created that utilizing it for research is really helping me just understand the problems and understand what I can do to start jumping towards these problems. So if there's any questions you have, any comments, ask away in the comments. I will answer. I'm really good at answering everything. If you want anything specific, also leave that in comments. Other than that, like and subscribe. Help me out. Let me know that you guys are at least interested in this stuff so that I can continue working on it. Usually I have these big gaps, especially this next one between videos, because AI just overtook me, and now it's just feeding into the system. How do I utilize it? How do I make it work for me so that I can get this? So if you're also interested in the AI side and how I get that to work, like in my Obsidian notes or in my video production or in my daily research, also ask. I can create a video on that. But yes, I believe Claude Code is a great tool for someone who is new to ROS or robotics, just because all that boilerplate ROS 2 code is now thrown out the window. And now I'm more just saying, okay, I have these 4 sensors, make a launch file, put all the drivers in so that I can utilize it. And then again, navigation, teleop, all these are kind of standardized in ROS 2 already. So I just tell it I have to use Humble, I have to use these devices, and it knows what to do. It's all standard. So yes, in the past, my dread ROS 2, now I don't have to worry about it. So hope that helps. If you have any questions, again, please leave a comment, like and subscribe. This is Rico with Maker Code. Have a nice day, and you can kind of see navigation didn't work, but I kind of understand why and what I need to do next to see if I can improve on that. LiDAR, depth camera, whole sensor fusion.